No. All right, I want to look at an example of a problem that involves fractions in the solving of an equation. In this particular example, the fractions do not contain denominators that have variables in them. So the only thing in the denominators of our fractions are numbers. So in this type of equation, we need to clear the fractions out of the problem by multiplying by the, really we could multiply by any common denominator. I'm actually going to use um, the least common denominator. So multiply the equation by the least common denominator. And in this case, that is 30, because 30 is the smallest number that both denominators divide into, leaving a 0 remainder. So 5 divided into 30 is 6, and the remainder is 0. 30 divided into 30 is 1, and the remainder is 0. So 30 is the smallest number that both of these denominators will divide into evenly. So in this next step, I am going to clear the fractions by multiplying every term of the equation by our least common denominator. So I am going to do that in this next step. And that means I'm going to be multiplying x over 5 by 30. I'm going to be multiplying negative x over 30 by 30. And an easy thing to forget is that even the terms that don't involve a denominator have to also get multiplied by that. Really, you can use a common denominator. We happen to be using the smallest or least common denominator. All right, now when I multiply a fraction by a number or another fraction, I'm actually multiplying numerators by numerators and denominators by denominators. And 30 is the same as 30 over 1. So I can either leave it as 30 or I can write it as 30 over 1. So the whole point here is to clear the equation of fractions. So instead of actually multiplying these out, I've carefully selected this number so that each denominator divides evenly into this LCD. So 5 divides into 5 once. 5 divides into 30 6 times. 30 divides into 30 once. And so I no longer will have any fractions remaining in the problem. So when you do this, the whole point of what you're doing is to rid the problem of fractions. So I now have x times 6 minus x times 1 equals to 12 times 30. 6x minus x equals 360. So 6x minus x is 5x. That's the same as 6x minus 1x. And that equals to 360. And I'm now going to isolate x by dividing both sides of the equation by 5. So these 5's divide out, and I'm left merely with an x on the left, and 360 divided by 5 is 72. So this leads to the result that if I replace x with 72, the left side of the equation will equal the right side of the equation. One thing you can always do when you're solving an equation is you can always check your solution in your original equation. So I'm going to replace every x in the original equation with 72. Okay, so 72 over 5 minus 72 over 30. My real question here, I'm asking a question, is this indeed equal to 12? So is that 12? Well, I can't subtract fractions until I have a common denominator. And what I'm going to do in this case is I'm going to change the denominator of 30 to a denominator of 5. And I'm going to do that by dividing the numerator and the denominator of this fraction by 6. So you can either multiply or divide both the numerator and denominator by the same number, and you don't change the value of a fraction. So I now have 72 over 5 minus 12 over 5. And my question is, does that actually equal 12? So 72 over 5 minus 12 over 5 is 60 over 5. Once that denominator is the same, I merely subtract the numerators and leave the denominator unchanged. So in order for me to subtract, the denominator has to be the same. And remember that 60 over 5 is the same as 60 divided by 5. So 12 does equal to 12. So I do get a true statement. So that is true. So that means that my solution set, I believe the problem on my math lab was asking for a solution set. So my solution set contains 72. So 72 did make the left side of the equation equal the right side of the equation, which had a value of 12. So that's how you work this type of equation that is actually a linear equation that involves fractions whose numerators are simply numbers.